Today we're going to talk about extended distance clusters supported by storage virtualization and network virtualization. So we're to the point where we can virtualize everything top to bottom. And this is basically a hyper availability solution. So we'll get into as many details as we possibly can for you. Standard disclaimer, lawyers got to get their fingers in everything. So, and I'm sure that if you guys are interested in the disclaimer, you can check it out later. Now, we realize that this is kind of a big agenda, but we're going to do it justice for you. So each of these probably will have a couple of slides because this is a pretty complex topic, to be completely honest with you. So we're going to make sure that, that we run through this stuff fairly quickly. If you got questions, this was the last session of the day. Come ask us afterward. You can ask questions, anytime you want. But if we got healthy discussion, by all means, feel free to come ask if you need more details. We got plenty of time, and so if we're running over something quickly, don't hesitate to come hit us up. All right, Sudhir, all right, this is my esteemed colleague.
Compadre. Yeah. Good afternoon, guys.
Partner in crime.
Partner in crime. My name is Bala, and I've been an Oracle DBA, an Oracle architect for the last 20 years. I joined VMware in 2012. I did services for almost like 2 years, and now I'm part of the Global Center of Excellence, where pretty much it's a pre-sales role. I talk to customers about performance tuning, anything and everything to do with Oracle on vSphere, be that licensing or tuning. So pretty much that's a bit about me.
Okay.
Thanks, Marlon.
Thanks. And I'm Marlon McNeil. I'm the CTO and co-founder and principal Oracle architect for the Yucca Group, based out of Albuquerque, New Mexico. So been involved I worked at Sandia National Laboratories for a while. That was kind of fun. Had some interesting projects there. Worked in the private sector at a software developer for a lot of years, where I got clear up to my eyeballs in Oracle, and that's where we discovered some of the neat things we're going to talk about today. So, which was really nice because it was on somebody else's dime. That's always good. And I've spoken at several different conferences around, and was one of the technical editors on the virtualizing Oracle databases on vSphere right there. So I read that book about 3 or 4 times at least, every section, and so anyway, good book. There's a lot of good information in there that will help you, give you a good solid roadmap for virtualizing Oracle and for virtualizing Oracle successfully on vSphere. Let's put it that way. Now, just to give you a little bit of background, being from Albuquerque, since I have a life and because I've spent all my free time learning how to do this stuff, I never watched Breaking Bad until about, I don't know, 3 months ago. And I finally decided I should educate myself. So I got on Netflix one night and checked out 3 or 4 episodes of Breaking Bad. And one thing that I think this will tell you a lot about what goes on in my head outside of non-VMware hours is, when the first drug deal went down in the junkyard, I recognized the junkyard. So anyhow, I know that's grim, but that's the way it goes. So, all right. Well, first of all, we're going to talk about traditional cluster deployments. And all y'all know about traditional clusters, right? So vSphere, high availability clusters, Oracle Real Application clusters, they're all built with connected computers that support each other, and you have failover, high availability, so that the nodes will support all the functionality. If any node goes down, functionality will move to or migrate to another node in the cluster. It gives you the opportunity to scale. So you can scale either horizontally, add more nodes, or vertically, add bigger nodes, or both, depending on your requirements. And typically, the traditional ones were in a single data center. Oddly enough, the very, very first one I ever did was a DEC VAX cluster, which was over fiber underneath the parking lot between 2 buildings at Sandia, which was kind of interesting. So I kind of got my introduction to wide area clusters way back when, about 25 years ago. And typically your cluster requirements, although this was not the case for that VAX cluster, that ran across a 10 megabit interconnect, if you can believe that. And I look back on that and I just have to chuckle and think, wow, I'm amazed it even ran at all. So But typically, we've got 1 gigabit interconnects between all the nodes, and at least one, most of the time 10 gigabit for storage interconnect on the back, and use jumbo frames and all that, so you get much higher elevated throughput, and your clusters work great. They're solid. They protect your applications, and away you go. And they've been traditionally in a single data center. Now, my second cluster, after the one that the government paid for, looked really, really a lot like that one right there. So I know PC Magic and the local Ace Hardware really loved me for that. Then extended distance clusters came along. And those are exactly the same as, they have the same characteristics, the same requirements, the same everything as a cluster in a local data center, except for that some of the nodes are in one site and some of the nodes are in another site. So that introduces a couple of extra constraints, and we're going to talk a lot about those constraints today and how we can deal with those effectively. So primarily, some of the clusters that you guys are familiar with most likely are Oracle Real Application clusters, and they require 5 milliseconds of latency or less in between sites. Same thing with vSphere Metro Storage clusters, right there. For all your licenses except for Enterprise Plus, they require 5 millisecond latency. Enterprise Plus, you can do 10 milliseconds latency. So, and then most of your storage vendors to replicate storage between the sites require somewhere from 2 to 5. Some of them a little bit over that, but for the purposes of our discussion, since rack is on top and it's bounded by 5 milliseconds, we're just going to call all latency in between sites 5 milliseconds for purposes of this discussion. And if you got questions about stuff individually, come holler. We got some information on some of the, the variation of those things. All right. So one of the fun things about extended distance clusters is getting the information back and forth between the sites, right, in a timely fashion. Not on 10 megabit Ethernet, by the way. And so, speed of light in a vacuum is 3 times 10 to the 8th meters per second. In fiber optic, in glass, it's 2 times 10 to the 8th meters per second. So it's 200,000 kilometers per second. That amounts to 200 kilometers per millisecond, or 124 miles per millisecond. So then you might ask, okay, so that means your extended distance clusters can be way far apart, right? Well, let's talk about that for a second. First of all, we have the speed of light, right?
If I can.
No, it's packet loss.
Exactly.
All right. Speed of light. Then we have to have round trip latency. So that's over and back, right? So now what happens if you don't have enough money to have dark fiber between your sites? Then you have store and forward.
That's good.
So then all of a sudden your latency goes down your latency goes up and up and up and up in a big hurry, right? So at that rate, so we're not talking line of sight distance, we're talking cable distance, which is all over creation, plus store and forward, hops and all of that stuff. And so what it boils down to is if you're looking at the safe parameters for distances between data centers, anything below 50 kilometers, you're pretty safe. Pretty much everybody, Oracle, VMware, everybody that I'm aware of, all the storage vendors, say 50 kilometers, no sweat. You're good, piece of cake. They all say, yeah, between 50 and 100, maybe. So what you got to do there, since you're outside of the guaranteed safe zone, is you got to test like crazy. And so you might ask, well, gee whiz, that's all really very expensive, right? Well, we're actually going to talk about how to test so that you guys can figure it out on your own and for not very much money either. So that's coming here in just a few minutes. So hopefully you guys will get some real value out of that. We've had some very good success with messing with that in our lab. And we'll talk about that a little bit more here in a few minutes. So yeah, clusters are stable up to 50 kilometers, possible up to 100 kilometers, but you got to test the dog out of it under your workload, under, with the characteristics of your carrier's data communications network, all that kind of stuff. And then there are several documents from Oracle that really go into great detail on how all that works. Okay, so use cases. High availability, not disaster recovery, different things. So basically, extended distance clusters protect against local disasters. You know, an airliner crashes into your data center, right? Well, if you got one 30 kilometers away, you're good. You keep right on going, life is good. So it's more of a disaster avoidance strategy, actually. Then workload balancing across sites. One of our case studies from a global, they were 786 in the most recent Forbes Global 2000. So we'll talk about them in a minute. They balanced a workload of about 20-something thousand users across 2 sites using this method. So we'll talk about that in a second too. And then of course you can do site maintenance. If you need to, you know, forklift a data center, you can forklift the data center without any interruption in service with 0 RPO, 0 RTO, away you go, completely rework your data center, migrate your workloads back, and off you go. Okay, so misconceptions. Here again, the disaster recovery as opposed to disaster avoidance argument, right? So this is, again, not disaster recovery. We'll talk about that too. So Sudhir he's the disaster recovery man. He's got some good stuff for you on that. Then the clustering is within sites, but it's also across sites. And so it's not components, it's across the whole entire site. And most of the time, here's another common thread that you will see running through this whole entire presentation. Everything requires a third-party witness site. So you have site A, site B, and then a third-party witness site so you don't get a split brain, right? And a split brain is where this site thinks it's the main man, this site thinks it's the main man, and they get out of sync, and then life gets really ugly after that. So they have a third party, or not a third party, but a third witness or quorum site that prevents those split brain types of issues going on. And doing extended distance clusters isn't necessarily inexpensive because you're talking about wide area data communications, you know, some extra storage virtualization, stuff like that. So there is some extra expense that goes into it, but you get a lot of value back out of it in terms of availability of your applications and things like that. Okay, now, one of the things, the main components here that goes into an extended distance cluster is you've got to virtualize your storage across, you've got to virtualize your network across so that you can get layer 2 adjacency. Now, you don't have to virtualize your network to get layer 2 adjacency, but it's a whole lot less expensive too, right? And so we'll talk a bunch about that here in just a second. So right now, a distance extension of layer 2 network, so you need layer 2 adjacency. So in other words, anything sends out a layer 2 broadcast at site A, that broadcast goes across to site B so that you can have a VM with IP address 1.2.3.4 can migrate to this site and still have IP address 1.2.3.4. So there, in other words, there are no router hops in between. It's all switch fabric. Either switch fabric or a virtual private net, or, yeah, a tunnel, basically, which is most of the time these days a VPN. So it needs to be a flat layer 2 broadcast domain. And then carriers provide these kind of services, MPLS, WDM, wave division multiplexing. Those are kind of expensive, and you get to the joy of doing battle with your local telco. Or there's also network virtualization now, which really uncomplicates a lot of those scenarios. And we'll talk about some of the things that network virtualization can do for you. Those are much more cost effective, and they're becoming ubiquitous. Lots of the carrier grade equipment has layer 2 adjacency built into it these days in various flavors. And you can get it from many, many places. So some of the supported layer 2 technologies, of course, WDM, multi-protocol label switching, that's what you get from your carriers. VMware NSX. So if you guys pretty much had a pulse this week, you heard a lot about NSX, right? NSX is good stuff. And we'll talk a little bit more in depth about that here in a few minutes. You can also do virtual private LAN service, VPLS, and that's built into all kinds of stuff. Now, at the top, we have information on Brocade because they were very helpful. Their tech support guys got on the phone and helped us out a lot with that. They're not the only people who can provide that, but their carrier Ethernet router and their VDX switches, even though their VDX switch is more of switch fabric than a routing tunnel, but it still provide layer 2 adjacency. And then they actually have a virtual appliance, so then you don't even have to have a physical appliance. You can just virtualize it right on your ESXi host and away you go. And that's due for release in December. And then, of course, Juniper and Cisco have VPLS as well, and I'm sure that there are many, many other people who have that, and I even saw a open source implementation of it. I don't know how stable / usable / documented it is, but it might be worth messing with. And then, of course, there's the trusty Cisco OTV, the overlay transport virtualization. And that gives you nice, they were some of the pioneers in the layer 2 adjacency virtualization sphere to get away from WDM and those sorts of things. That comes with the Nexus 9000 chassis. So with that storage virtualization, Sudhir is the storage guy, and he will take good care of you.
Thank you. Thank you, Marlon. So see, Marlon touched about, there are two major parameters, right, that you have to keep in mind once we start talking extended distance clusters. The first one is the network virtualization piece, right? The second piece is the storage virtualization that I'll talk about. So the storage virtualization, basically you're abstracting the storage from the hardware. And what benefit does that give you, right? It gives you a lot of flexibility in your architecture design, right? You're able to co-locate or locate your storage in different locations, right? It also facilitates storage replication, local and remote, right? Some of the technologies, they are storage agnostic, right? So pretty much on a high level, there are two ways you could go about with the storage virtualization. The first way is host-based, right? And we'll talk in detail about the host-based. And the second way how you can go about it is the appliance-based, right? From an Oracle perspective, when we have to do a host-based storage virtualization, that would be using the Oracle ASM or the automatic storage management. When we have to do the appliance-based storage virtualization, you would either pick one of the storage vendors, right? EMC vPlex, we have NetApp Metro Cluster, HP Pure Persistent, IBM SVC, and then we have our own vSAN. And by the way, there's a beautiful session by Duncan Eppen and Rawlingson Rivera. That was on Tuesday, I think. And that was building a stretch cluster with virtual vSAN.
So then you guys go to that session?
And how was that?
Who else?
Nice.
Oh, sorry about that.
Yeah.
All right.
All right. So, I mean, the similar concept, right? You have storage virtualization, but now you are virtualizing your storage, or I would say stretching your storage across extended sites, right? Extended distance. So pretty much your requirements are still the same, right? You have the same latency requirement, very similar to the Oracle rack cluster interconnect, right? Typically what happens is frequently you would have to have matching vendor appliances on both sides, right? From a data perspective, bandwidth, right? That's the one that is doing the heavy lifting here. So your rate of change of data, it's very important, right? And typically what happens, you have to ship the seed, or you get a swing storage, sync it up on site A, ship it to site B, right? And that's how you do the initial sync, and then stuff goes over the wire, right? So that those are the important parameters that you have to keep in mind, when you go about with an extended distance cluster, right? So typically, benefits of storage virtualization, right? We already spoke about flexibility in the architecture design, right? You can also replicate. Replication could be done either async or synchronous, of course, that facilitates your extended high availability clusters, basically continuous availability on multi-site. The other cool feature that it gives you, or the flexibility it gives you, is creating storage pools. So you can create storage pools from heterogeneous vendors, right? You can have different vendors, or even with the same vendor, you can have different storage models. You can either mix SAN and NAS and say, you know what, for example, SVC, right? I have an SVC and all I care about it is the volume. I don't care whatever is behind it, right? That could be a NAS, that could be a SAN, that could be a different model, or probably a different model from a different vendor. But from my perspective, it's a volume. A volume is a volume is a volume, right? And the best part is we do have now virtual appliances available. Example, EMC vPlex, VE. And what storage virtualization also gives you is the benefit of centralizing the management of storage, right? And also, if you have to do data migration from one data center to the other, like what Marlon spoke, right? Well, let's say you're getting kicked out of the data center, or I have to do a data center migration. Storage virtualization helps you. So we spoke about two ways how you could go about with the storage virtualization, right? One was the host-based, and the other one was the appliance-based. Let's talk a bit about the host-based storage virtualization. From an Oracle perspective, the way you do storage virtualization is using the Oracle ASM, the Automatic Storage Manager. So for those who are not very familiar with what ASM means, see, basically you have file systems, right? And then you have volume managers. You can think of ASM as a volume manager. It's not mounted. All you have to do is give it a bunch of disk and lo presto, right? You have a volume manager where an Oracle database can write to and can read from, right? So this is storage agnostic. It doesn't care if it's a SAN, it's a NAS, if it's IBM, if it's EMC, or for that matter, storage vendor XYZ, right? It's bundled with Oracle. It's very easy to set up. This is one caveat that you have to keep in mind is there is a CPU performance hit. Because typically what happens is when you use host-based virtualization, you have to do synchronization, block synchronization, right? And that's what the CPU has to do. So, I mean, there are customers who are running host-based virtualization. There are customers who are running storage-based virtualization. It all depends on how big your servers are. If you have amples and noodles of CPU cycles, that's fine. You could go with this method. So there are two special configuration needs when you set up host-based virtualization using the Oracle ASM. You have to set up this parameter. That's the ASM preferred read group failure. See, what this means is this, right? I have a disk from site A, and I have disk from site B, right? I have a disk from site A, I have a disk from site B, and this guy sitting on site A can see both. But if I have to read to, or if I have to write to, which would be my preferred disk? The disk on the local. If I'm here, and if I have to read to or write to, which would be my preferred disk? The disk up here. So basically it's saying, I prefer reading from the local disk. Sure, if the local site goes down, I have no choice but to read from the remote disk. But if given a choice, I would read or write from the local disk. So that's what this parameter means. The ASM fast mirror resync basically says anytime a disk goes offline, I have up to 3.6 hours before. I have up to 3.6 hours to work to make sure that the disk comes online so I can do a resync, right? And the requirement is the disk group has to be normal. What normal means is you need to have a disk and you need to have a mirror for it. So 2 copies. And of course, this requires a third site. This requires a third site for the voting disk. So you can have it as an NFS share on a third site. So you have site A, you have site B, site C is a third site. You can have a voting disk on the third site on an NFS volume, and you're all set to go. So basically, we need a witness in case of Oracle RAC. So if you have that cluster disconnect, if you have the cluster the fencing, who wins? Site A or site B? So that is decided by the voting disk on site C.
Just for the GWIS file, the voting disk at site C also works on iSCSI, if that helps.
Yep, good point, good point. So appliance-based storage virtualization, of course, it is relatively expensive. It's specific to vendors, and some of them have very strict storage requirements, and we will have a look at that in the subsequent slides. So I'm going to skip over this one. You guys already know what Oracle RAC is. I mean, that's the reason why you guys are here. And that's how it looks like. So an Oracle stretched RAC using the automatic storage management. If you can see here, that's the third site for your voting disk, and that's mounted via NFS. So pretty much, typically what happens is you will have odd numbers of voting disks. You wouldn't have 2, 4, and 6. You will either have like 3, 5, 7, and 9. So make sure that one of the voting disks is on the site C. So if bad things happen, definitely your cluster is up and running. Right. All right, let's talk a bit about the vSphere Metro storage cluster, right? So there are actually three clusters, or I would say 3 bands in play here, right? You have the Oracle RAC, you have the VMSC, or the vSphere Metro storage cluster, and then if you're using storage-based virtualization, you have the storage cluster, right? So let's talk about the second layer here. So the VMSC, as we very fondly call it, right? It combines synchronous replication with array-based clustering. You typically deploy that in a metro or a campus environment. And of course, it's disaster avoidance. It's not disaster recovery. DataGuard or SRM is disaster recovery. Oracle RAC is not disaster recovery. It's disaster avoidance. The reason being, it's a shared volume. All you have to do is nuke the shared volume and everything goes down, right? So, and it has the capability to migrate virtual machine between sites with vMotion or storage vMotion, right? And these are some of the latency requirements for the vSphere Metro Storage Cluster. Of course, FC is supported, fiber channel over Ethernet, iSCSI, SVD, 5 milliseconds. So Marlon already mentioned that. If you have an enterprise license, right, 5 millisecond RTT, Enterprise Plus, 5 to 10, but then we take what the application demands, and Oracle RAC demands, 5 millisecond or less. So let's just go with that, right? Of course, layer 2 equivalence, minimum 622 megabits per second, 60 kilometers is stable, and it's a real stretch after 50 kilometers to 100. So, you know what, mileage varies.
But you can test it, and we'll show you how.
Absolutely. And what definitely we would recommend is anytime you go about doing or going about this engagement, please make sure that you check the compatibility list. So your server, your switches, the model, the version, the firmware version, the BIOS version, make sure everything is compatible. So we spoke about Oracle RAC, we spoke about vSphere Metro Storage Cluster. Let's talk about the third layer. And the third layer is the storage cluster, right? The examples could be your EMC vPlex, NetApp Metro Cluster, HP Pure Persistent, IBM SPC, and Marlon will talk a bit about vSAN too, right? Stretch vSAN. So as usual, Oracle RAC will manage the node across the interconnect, right? So you have a virtual volume. Basically, you have a virtual volume. Underneath the covers, the storage cluster, right? The storage virtualization cluster, that keeps track of it. You know, it would make sure that the vSphere Metro Storage Cluster sees a volume, a virtual volume, right? And it takes care of, you know, concurrency, consistency. The storage layer does that. With the vPlex, we definitely require a witness because that provides your failure resiliency in case site A goes down or site B goes down. So if you have to run Oracle RAC on vPlex, or for the matter, any other storage vendor that I'm aware of, you do require some kind of witness to arbitrate between site A and site B. That's the same deal with using Oracle RAC extended on NetApp Metro Cluster. Again, your virtual volume is replicated over Metro Cluster interconnect. In the Metro Cluster, what they have is they either have a Windows service, it's called a tiebreaker, or a Unix daemon running. That is the arbiter between the two sites. If site A goes on or site B goes down, right, which wins? And using ONTAP 811, you can go up to 160 kilometers. But for our sakes, using Oracle RAC, we'll restrict ourselves to 100. Because till 50 is stable, 50 to 100 is a stretch. You know your limits.
Okay. All right. Thanks, Sudhir.
Thank you, Marlon.
Appreciate it. Okay. So yeah, all of these. By the way, all of these diagrams that you see, minus the RAC part on the top, we picked off of VMware KB articles. So you can, if you've got interest in any of this stuff, any of these technologies, you can get in, just search the Microsoft, heaven forbid, the VMware KB, and you can tell where I spend time. And you'll be able to get these articles, and they have lots of good information. They have all the failure scenarios that are supported, listed out, and all kinds of good information about latency and distance and all sorts of good stuff. And you'll notice that there's the common thread of distance, of latency requirements in between. They all have the third, either witness or quorum site, depending on what they call it, but it's the same, the anti-split brain site. And so here we've got HP Pure Persistence, same basic deal. The HP Pure Persistence, of course, works with HP storage on the back end. But it does the same deal. So RAC takes care of the RAC nodes on the top by itself. So the storage doesn't have anything to do with RAC, or at least the management of it doesn't. And the volumes, of course, are synchronously replicated, and they'll take care of themselves in terms of something gets out of sync, and we'll get back in sync, and those kinds of things. You have, again, the quorum witness, which one of the things that tickles me about this one is that the quorum witness is a VM. It's a virtual appliance, right? So it's not nearly as intensive to stick that at a third site somewhere. And then, of course, the IP subnet on this one, this is kind of an interesting requirement. The IP subnet that your ESXi management address is in also needs to be the same IP network in the same layer 2 broadcast domain, right? Where your guest OS IPs are. Interesting little caveat on that one. So, and then with IBM SVC, pretty much the same situation going there. And now, SVC, one of the neat things about SVC, kind of like vPlex, is it's storage agnostic. As long as you got fiber channel storage on the back end, you can hook it up to SVC, and then SVC can replicate it, make sure that all your virtual volumes that are presented up to your Oracle cluster stay in sync. But as long as it's fiber channel on the back end, you can have any kind of heterogeneous storage that you basically want. So but it's got the same thing. It has, again, a witness site. Now with SVC, it's a little bit different. You got to have some IBM storage at your witness site, right? That's in an IBM storage chassis of some sort, and it has 3 disks, so it's fairly robust because there's 1 active disk and 2 passive failover disks. So if one of your disks dies, your active one dies, then you got 2 backups. So that's helpful in terms of having good availability of your storage replication subsystem. And again, this goes up to 300 kilometers, which is quite a ways if you've got dark fiber. But when you start adding hop, store, and forward in, and I put that in a spreadsheet this morning just to be ornery. And after all is said and done, it works out to about, in the most of the scenario that most of us are going to be dealing with, about 5 milliseconds. So we're back to that 5 millisecond common thread again. All right. Now here is from the session that Duncan Epping and Rawlinson Rivera put on, which was a fabulous session, by the way. We actually stole these slides from them. They were kind enough to let us use those. The vSAN does basically the same thing. This is VMware's version of hyper-converged architecture, right? But it also has the capability of replicating storage from one site to another. Now, when I was watching this, then this is just some interesting trivia, right? That may or may not, tickle you. But one thing that struck me about vSAN was that the way it works is very similar to the way ASM disk groups work, which is in Oracle, the Oracle Automatic Storage Manager disk groups. And those have been really, really rock solid. We'll talk about a case study that utilizes ASM here in a second. And that works really well. So when I saw the paradigm and I was immediately able to wrap my brain around it, I had to smile because that strikes me as a very nice, stable, even though it's new, they're using proven concepts to make it work. So here you can do it in one of 2 different ways. You can either do it with your traditional layer 3 network, however you get that, in between your sites, and your traditional layer 2 adjacency. So if it's OTV or whatever, right? Or VPLS or however you get layer 2 adjacency between your sites. And that works just great. Life is good. And you have, for your witness site, you have an actual ESXi host that is in a virtual appliance. So how many of you guys have nested VMs and put ESXi inside a virtual machine on ESXi? Ooh, this guy deserves a squeezy ball right there. Awesome. Okay, everybody hold that thought because that's going to be super duper important here in just a second, okay? Now, the next one we got here is this is where they've got a scenario that's supported where you can use layer 3 networks across the board. So you don't have to go to the extra expensive MPLS, WDM, whatever, right? You can just use vanilla, generic, old layer 3 networks across, which are inexpensive and easy to come by and easy to deal with. The thing that makes this situation work in terms of keeping that storage replicated and in providing your layer 2 adjacency is NSX. So the marriage of vSAN and NSX together work very, very nicely. So that kind of uncomplicates. Then you got, one neck to choke, right? as it were. Because then you can go to VMware tech support for any of your issues that you might be having. So that is not a bad way to go. has some distinct advantages, and it's very elegant. You've got basically a single pane of glass for management. And if you go with a vendor like Blue Medora or Confio, you can have your management of all of your VMware and your Oracle in a single pane of glass. So they make that nice and all consolidated, which really improves the visibility of your applications to your storage and network administrators, and of your compute, storage, and network to your application administrators. So there's lots less finger pointing. Okay, so now we've gone through the disaster avoidance parts of things. We're going to talk a little bit about the disaster recovery, which is also important, because there's nothing that says that you can't have two sites that puke, or that your rack decides to corrupt data, which that's never happened before. Never, never, never.
Thank you, Marlon. So you guys must have heard of the product, of course, SRM, Site Recovery Manager. So that provides disaster recovery across two sites. Then again, SRM is not the tool that does the actual disaster recovery. Right? It's not the tool that takes bits and pieces from site A and applies it to site B. It's a workflow engine, right? You would either have to use vSphere replication, for example, or any of your SRAs, SRA for EMC, SRA for HP, SRA for NetApp, which does the actual replication, right? So let's look at data card. In fact, you know what? Let me bring out a point here. There are three levels at which you could do a replication. Three levels. First is application level. An example for Oracle would be the Oracle data card, right? The second level would be vSphere replication at a virtual machine level. The third level would be storage-based replication, recover point, SRDF, you have NetApp solution, you have an HP solution, you have IBM solution, so on and so forth, right? Let's look at Oracle data card, right? So basically, data card is a tool provided by the Oracle Corporation, and that does the actual disaster recovery of an Oracle database, right? So pretty much log shipping on a high level, if we were to speak of it, right? A log redo writes, or whatever happens on site A gets shipped across to site B, gets applied on this particular database, and voila, you have a disaster copy waiting for you just in case disaster strikes site A. There's another version of data guard, right? And that's called active data guard. Of course, nothing is free from Oracle. It's expensive, right? But then the cool thing about that is you can have the site B database read-only. So it can be open while you're applying the redo or the logs from the primary. So what does that buy me? What does that help me, right? What happens then is if you have to have certain activities, right, happen at the primary, which you think you can offload to the standby, by all means, do that. So that's a cool feature. In fact, let's say a DBA were to go and say, oh, you know what, my active standby database is, of course, let's say it's behind my primary. I would like to go and see what happened to the data, let's say at 8 in the morning, right? Let's say my primary is at 8:30. Somebody went and did something, right? So you could get a before image before the accident actually happened, right? And if you have to recover, you have the mechanism to do that. So that's the Oracle data, the Oracle Active Data Card. It's an add-on option. It's not free. It's expensive, right? But then what happens is, yes, you can definitely marry SRM, Site Recovery Manager, with the Oracle Data Card, right? And the question that may warrant it here is, how does that happen, right? The Oracle Data Card does the actual replication, right? And you just told me SRM is a workflow engine. See, basically what happens is, the Oracle database is not the only thing that lives in a data center. There are web servers, there are app servers that use the database, right? You have to replicate those across the wire from site A to site B. So what we did was, we did a lab exercise, right? What we did was in site A, we had an SAP application connected to an Oracle database, primary, right? And site B, we had an Oracle database which was a standby or an active data guard for site A, right? And we emulated that site A went down, right? On the post power on the SAP virtual machine, we were able to go and inject a script that was able to change the mode of the database, the active data guard, from, let's say, standby to primary, and voila, you're up and running for business. So think about it, right? If you had, let's say, 1,000 databases that you're DRing over using Oracle Data Guard, your poor DBA would have to write that command or type the command 1,000 times, or at least run the script 1,000 times. You have SRM to do that for you. So ain't that cool? So this basically talks about the Oracle Data Guard, the vSphere replication or storage-based replication. I'm going to hand this over to Marlon to talk about his case studies.
Okay, thank you, Sudhir. Appreciate
you,
it.
Marlon.
All right, guys. So here's some really juiciness for you. So we try and these are going to be really useful because all these case studies have done very interesting things. And so the reason we included these is because it's got some information that'll be valuable to you if you're interested in doing any of this sort of thing. And the first one, this might, from the outset, look pretty vanilla. This is the 17th Judicial Circuit Court in Winnebago County, Illinois. We did this implementation between 2009 and 2010. And it uses ASM disk groups to virtualize the storage between two sites. So these guys had an Oracle-based OLTP court case management application. So this is for their courts to manage all their citations and who's in jail and who's not and when are they going to be released and who's dangerous to society and all that stuff. These guys, basically, that's a big enough county where they needed 24/7/365 access to that application. And the requirement, basically, was they needed 0 RPO, 5-second RTO, because of the nature of the guys who wanted to get reelected. Of course, that never happens either, right? But they did have 2 concurrent production sites, and they needed to load balance their users between those 2 sites, interestingly enough. Even though there weren't a truckload of users there were enough. And they needed to load balance them based on the functions of who was working in which buildings. And what they had was they had these two buildings. One was the old courthouse and one was the new courthouse, and they were 600 or 700 meters apart. And they somehow or other managed to dig a tunnel between the 2 of them under downtown, which I thought was interesting. And so they ran dark fiber underneath the 2, right? So they basically had the advantage of having dark fiber, 2 1 gigabit links all the way back and forth between the 2 sites. They had 3 data centers. They had the one in each courthouse and one in their administrative building across the street. And it's right around a kilometer of distance between the 2 sites. So it wasn't a super long distance. And of course, then they had all kinds of bizarre iSCSI stuff on the back end, right? It's like every flavor of EqualLogic you can imagine, and some iSCSI, some open filer iSCSI even, if you believe it or not. Anyway, that's what they had to start with. And what they wound up doing was using ASM disk groups. Now, the deal is this was a physical site, but here's where the magic is in this case study. That physical site, let me run through some of the specs first of all as to how things wound up working. So they had 2 production sites where users were running this court case management application at both sites. And then they had the 3rd voting disk in the data center up in the admin building across the street where all the IT offices were. And with Oracle, they used normal redundancy and ASM disk groups. So they had 1 disk in one site, 1 disk in the other site, normal redundancy between the 2 so that those 2 disks were in the same disk group. And that's how you got the replication going between the 2, right? And then, of course, we did ASM preferred read failure group so that they read from the local site at each side. And so they were reading somewhere between 90 and 96% of the traffic was reads, and only between 4 and 10% were writes. So all the traffic was coming locally, and every once in a while a write would have to go over the network back and forth. So that was a super good thing. And we were able to configure all that in the Oracle ASM implementation. And then, of course, their rack interconnect. Now, here's what we did because the entire county of Winnebago used those 2 strands of fiber, right? But what wound up happening was after about an hour's worth of collaboration, we decided to put quality of service on the interconnect. So the Oracle rack interconnect got higher priority. Well, I take that back. It got higher priority than anything else except for voice over IP. So the interconnect traffic and the voice over IP traffic got the same priority, but they were higher than everything else. And so even over a cluttered network, we got nice performance, no evictions or anything like that, because we elevated the interconnect traffic to the highest priority, and off it went. And it's been rock solid for, well, since 2010, so for 5 years. Actually, since late 2009. And then we were doing Oracle Streams replication to a third data center just for the gee whiz file. That was kind of their disaster recovery site / public access site. So if somebody hacked it, they wouldn't corrupt the other data in there. Now the magic of this was that for about 4 months, it didn't work. It did, but it would crash 4 or 5 times a day. We'd have node evictions all the time. We could not figure it out. And so what we wound up doing, and of course, I being the vendor guy who was, implementing rack, I was taking all the heat. And so I came back one day, and I decided, okay, I need to figure out what the heck's wrong with this thing. And everything looked pristine and perfect and beautiful. And so I figured that I needed Salud. I figured that I needed to replicate it in a lab and just start, eliminating pieces until I found out what was wrong. Well, I get back and I don't have anywhere near enough equipment to replicate that. Not even close. But I did have one great big server sitting there that I hadn't deployed yet. And I had learned about ESXi, I don't know, 2 months earlier. And I'm like, wonder if we could virtualize this thing. 2 days later, we had a complete extended distance rack cluster that looked just like that, which looked just like the physical one, up and running. 2 days. And I hadn't learned all the make it go fast tricks yet, but the thing was rock solid. About the only way to kill it was to pull the power plug out of the server, right? It ran flawlessly. And because of that, we were able to start eliminating pieces, eliminate, until we got down to buggy HBAs from a vendor who shall remain nameless. And I hear that they have since fixed the issue. But once we ditched those HBAs, it's been rock solid ever since. And so, but it took me about 3 seconds once we got that rack virtualized to realize that we were onto a super good thing. Because then all of a sudden, then you've got vMotion at both sides. You've got, HA clusters at both sides. Man, they're just, the possibilities open wide up. And that was the real magic of this site. So that's why we included this here. And it introduced us to the concepts of storage virtualization. And then we didn't have to deal with the layer 2 because we just had a really big, long Ethernet. So that led to an implementation that looks more like this one. Now these guys were in the 2016 Forbes Global 2000. These guys are 786. And they had the same basic deal, except with 24,000 users instead of 320 users. But they basically had the 24/7 by 365 availability requirement. They had 2 concurrent production sites. They weren't quite distributed 50-50, but most they had their employees distributed between these 2 sites. And they had 0-second RPO and 5-second RTO requirements. And they actually are a bandwidth, they're a carrier, so they had plenty of bandwidth. So bandwidth wasn't an object to them. It was about 70 kilometers between the production sites. And they had EMC storage on the backside, right? So we had a huge discussion about whether to use the ASM-based storage virtualization to replicate the storage between the 2 sites, or to move down and use a virtual appliance or an appliance to do that. They opted for the virtual or for the appliance because they also had other stuff they had to protect. They had their SAP and everything else in addition to their database they had to protect. So I think that was the right decision they made there. So what it wound up looking like was basically this. They had vPlex right there that took care of their storage virtualization and had some big arrays on the back end. They have a vPlex witness at a third site, and I'll show you an actual architecture diagram of this in just a second. And then they put rack on top of that, along with all their other stuff. So they put 4 nodes, and then they used Cisco OTV. They used OTV to get the layer 2 adjacency between the 2 sites, and because I'm assuming they already had Cisco gear as well. So Synchronous replication, extended distance rack, 2 production sites. They ran vSphere Metro Storage Cluster to protect everything else, rack to protect their database, and they virtualized their SAP, so they're 100% virtualized on all of that. So their rack is virtualized, their SAP is virtualized, whole shoot and match. And they are projected to run it up to 12 nodes per site. They had 4 nodes and 4 nodes when they first started off, and they've been scaling as they're going. So, and here's their actual architecture diagram. So you can see they've got OTV right there. And then their ESXi Metro storage cluster on top. And all of their virtual LUNs right there are all supported and provided by the VPlex, the physical appliance, as opposed to the virtual ones. The virtual one was not released when these guys did this project. And then they have a third site where they're doing Site Recovery Manager and Data Guard to protect so that they have disaster recovery as opposed to disaster avoidance. So this is the disaster avoidance side of things. That's the disaster recovery side of things right there. And here is actually physically how it was implemented. So if any of you guys are interested, there's, they've got VMAX, several VMAXs all the way across, and Vplex engines on both sides and things of that nature. So if you want to look at that in more detail, holler. Be happy to show it to you here after the fact. Now, in light of those, we've got a use case for a small technology startup out of Silver City, New Mexico. I know all of you guys have heard of Silver City. Anybody heard of Silver City? Oh, look at that. There's 3 more virtual balls here. Okay, who's that? Right there? Right there. And who is the third person who heard of Silver City? There. Oh, there we go. All right. Yeah, Silver City. There you go. And so, yeah, Silver City has a Division II university in it. There's maybe, I don't know, 15,000 people in town or something. And, but they had financiers, or the financiers for this venture. Now, it turns out that these guys are doing internet payment security and fraud detection and prevention. And so, globally, so they have the same kind of availability requirements. They have to have 0-second RPO. They cannot lose a transaction because all of those are some of them are fairly large financial transactions. And they need 5-second RTO because most of their clients have very, very strict SLAs on the order of 18 milliseconds, right? So they can't screw up. And if anything goes haywire, it's got to recover right quick. And so the solution for that, of course, was extended distance clusters, rack on vSphere Metro Storage. Now, it turns out that these guys are 100% virtualized. We had the luxury of designing their data center from the ground up. And so I saw to it personally that these guys got to be 100% virtualized. Introduced some interesting caveats in terms of PCI compliance, all of which we were able to handle. But if you want to talk about that, give me a holler offline. I'll be happy to tell you. And so what they've got, now here's the deal. So I've heard that after watching 4 or 5 episodes of Breaking Bad that, what's the guy's name? Eisenberg? Mr. White. Okay, and Mr. White he's the drug kingpin in Albuquerque, right, where I live, and where their data center is. Their data center is virtualized in a nice little colo downtown among trendy little restaurants and a nifty movie theater. But the deal is that's not going to do it. That's not going to give them that kind of availability. Because it's New Mexico, there is only one other place in New Mexico where that other side can possibly go. Let me rephrase that. There are only 2 places in New Mexico that are close enough together, yet far enough apart for that to work. And those happen to be Albuquerque and Santa Fe. So the question is what would Mr. White do to support the availability of his drug running operation with vSphere Metro Storage clusters on our supporting rack? And I'll leave that one to your imagination. I have no idea. But I guess that he would have a highly available enterprise given the piles of cash that I'm assuming he's generating. The downtime would be expensive. So, and the same thing goes for these guys here. Now, the deal is between Albuquerque and Santa Fe. That's about 100 kilometers of distance, right? But we didn't have a choice. That's what you get in New Mexico, because there's like 14 towns in New Mexico that are bigger than 3 people apiece. And so this leads us to our next interesting situation. So because they have about 100 kilometers of cable distance between Albuquerque and Santa Fe, guess what? We got to test the dog out of this application before we run it live. And these guys are on a startup budget. They just don't have the cash to throw at all of this infrastructure. So what we are currently doing as we speak is we are running up a test environment that's 100% virtualized in our lab so that we can test that workload at that distance. And actually, it turns out that we found enough pieces that we can do it for that much money, which is really fantastic. And so we're going to talk about how to do that so that all of you guys can go back, and if you're interested in doing this, you can build yourselves your own lab for no money, minus a server, right? That will help you figure out, is my workload viable over this distance? Or maybe even better said, what's the farthest distance I can make this workload viable at? You can just extend the distance out and test it again and keep extending it until it breaks, kind of thing. So we are currently doing a proof of concept for these guys where we're testing their workload. And it's 100% virtualized. You can virtualize it on one box. And here's where the nested ESXi comes in really handy, super duper handy. Because then what you can do is you've got ESXi, the physical layer, right? Well, then you build a virtual machine here and put ESXi in it, and a virtual machine over here and put ESXi in it. And then you put VMs on top of those, which are your 64-bit Linux rack hosts, right? And so away you go. Then what you've got is then you have virtual switches in between. Well, and one of the really nifty things that I've discovered, that our crew, our team who's doing this discovered, is there are open source x86-based WAN emulators. And so then we can adjust the parameters, poke it, and make it however long we want. And you can adjust the distance and then rerun the workload and see what we get. Right? And we can do it all on one server. And the deal is right here, we're minimizing the risk of project failure because these guys don't have enough money to fail. I mean, it's got to work right the first time. It's easy. It's low cost. We can do it in a very, very compressed time frame. We can do it in like a week, right? So we're actually about halfway through it as we speak. And that way we can make sure that we get the production results right the first time. So we minimize the business risk for these guys. Okay, and not only that, we can build the whole entire thing in a secure network zone because we have to use production data to test that workload, right? So we can build it inside a PCI level 1 protected security zone, and we can still make it work without compromising PCI, which is really fabulous. So, okay. So here's the, actually, we'll talk about that, about the architecture of that in a minute. What we've got is a couple other case studies of interest. These aren't exactly virtualized storage with virtualized network with metro storage clusters with rack. However, we have discovered that Violin Concerto has a production site that runs, that's currently in production, that runs nicely. So something to think about. So here's the proof of concept. Basically, you put your WAN emulator in between two vSwitches right there, and then you put each ESXi virtualized host on each side, and away you go. And you can use OpenFiler, FreeNAS. We use OpenFiler because that's what we found first, but other ones work well as well. For the virtualized storage, so you just put a VMDK file on each side, run it up, and share it out over iSCSI. We have been working with WAN emulators. I personally am leaning toward WAN-M at this point because it's currently meeting our needs better than the other stuff, but they all have their idiosyncrasies. So whatever one works for you, DummyNet, Net Emulator, there's a bunch of them that are out there, and they all look like they're pretty decent. I happen to like the documentation on WAN-M. And then you have to use nested vSphere right there, and that really solves lots of problems. That can reduce the size of your lab a lot. Now, here's the neat thing that we discovered is just recently, in the last like 3 months, EMC released their VPlex Virtual Edition trial. And the thing that really made that useful for us, it was very timely for this project, is that you have a full use VPlex license that runs in a virtual appliance that's free forever, as long as you promise on your honor not to use it in commercial production. So, and then of course you can get an Oracle development license, and at that rate, off you go. And you're spending money on hardware, and that's it. So you can even get a white box, heaven forbid. It's better to get something on the HCL, but anything you can get that has enough memory and enough processor to run a couple of virtualized ESXi hosts, and away you go. Okay? This is what the architecture looks like. So you can see we put OpenFiler as the storage on both sides. And then VPlex Virtual Edition to make the storage virtualization work. And then we did another OpenFiler SAN up here for the voting disk site. And then we have virtualized rack nodes in between. And then your WAN emulator is right there. So that's your reference architecture for how to put that all together. And you can do that for effectively no money. And this is how your DataGuard architecture looks off to the side. Very, very much like the implementation with Telkom Indonesia, right? So there's our conclusion.
So coming up with a conclusion, right? So we spoke about stretch clustering. We spoke about how we could do stretch clustering, especially for Oracle RAC, using host-based or storage-based virtualization, right? We spoke about Oracle DataGuard, and Oracle RAC is not disaster recovery, it's disaster avoidance, right? Everybody's doing it. Marlon did a wonderful job of telling how you're able to build your own POC for practically no money. So I hope this session was very useful to you guys. We hope it's very useful to you guys. There are some couple of references that we include in the slide. It's very good read. Couple of people we wanted to acknowledge. Did you want to call them out? Or?
Oh,
absolutely.
Sure. Yeah, we've got Todd Hughes with the 17th Judicial District, was hugely helpful in facilitating the whole project beginning to end and gave us all kinds of help. Halim Sulismano with Telecom Indonesia, Wayne Wilkinson with Simple Logic Systems is the CEO there, and he's been supportive of this from the word go. And several folks from HP, EMC, NetApp, VMware, we got huge input from all the vendors. Everybody was super helpful for this. And we tried to make this as vendor agnostic as we could, right, so that you could get a broad picture of what's available and hopefully map it onto some technology that you've got kicking around.
We got some good help from people from Violent Memory and IBM too, so let's not forget them as well.
Yes.
And yeah, so I'm sorry, apologize, we don't have any time for Q&A, but please do fill out the survey. It is very helpful for us. And there's one thing, yeah. IOG.org, so we have a dedicated VMware SIG. It's I don't know how they allowed it, but they did allow it. So typically Oracle doesn't love us, but they did that. So I would highly encourage you guys to sign up for the IOG. It's free. And typically what happens is questions like, extended Oracle RAC on vSphere Metro storage cluster using this kind of storage virtualization, right? I'm running into this problem. Help me. How do I solve it? So you have experts like us who would go on, give suggestions. We might come up with case studies. We might come up with some kind of blog articles. But definitely, when you get a chance, please do sign up for the IOG. And I guess, thank you guys. Thank you for coming. I hope you had a good VMworld presentation. Thank you very much.